assessment services for the practice. And I wanted to provide that context before I start continue with the presentation. So to provide some overview of the agenda for today, I'll talk about a little bit about Foundstone for those that are not familiar with the Foundstone name. And then I'll jump a little bit into the software security maturity assessment services that we provide. And as I do that, I will actually introduce a case study with one of the organizations that, and some of the organizations that we have worked on for that matter, to provide examples of how we did the assessment, and how we applied some of the security activities. And then at the end, we'll have a summary and wrap up all the presentation, and we'll have some time for questions. So for those that are not familiar with Foundstone, internally we're basically known as the Navy SEAL expert team for the business. Foundstone was founded in 1999 and was acquired by McAfee, and then McAfee was acquired by Intel, which is now we refer to as Intel Security. So it's good to understand some of the history behind us. And our expert team, or team of experts, I should say, focus on delivering all kinds of security services from a tactical consulting and strategic and training point of view. Some of these services, as I mentioned in the past, are things like providing web application penetration testing services, internal and external network assessment. We also do mobile application penetration testing, also threat modeling, and some remediation and guidance as part of our methodologies. And in addition to that, there's also some strategic consulting service that we offer, such as PCI, risk assessment, and other type of risk assessments such as SOC. We also have a group that focuses on training, delivering training. We offer things like writing secure code for .NET and Java. We also have a training course for building secure software, which is kind of touches more about the software design and secure architecture aspects of building software. And the ones that you're probably more familiar with, the ultimate hacking web and whatnot, which are some of the books that you've probably seen in the libraries, and most of us, some of us have been authors or have contributed some of the material to these books. So in a sense, that's how we basically provide security services, and we provide a complete coverage. Not only from a North America region, but also from a global perspective, where we offer these services from different regions as well. One thing I'd like to mention too is from a Foundstone, to give you some context about us, is that we most of us as consultants and members of the Foundstone organization, we try to contribute as much as possible to conferences and local events, right? So like the Black Hats and the ShmooCons and DEF Cons, we have at some point spoken into these events. And I personally I'm a contributor of the OWASP, Open Web Application Security Project community. I'm actually a project co-leader of the Open Software Assurance Maturity Model, and I have been doing I led the chapter for a while in Minnesota, and I've been contributing to that community for about 8 years now. We also try to contribute to local events from a university level and college opportunities by providing some lecturings to NYU Poly and New York IT, to give you some examples. And another thing that is nice to highlight here is that we also have the Open Security Research blog, which is an open blog that we use, where most of the members of our organization post security research information there based on previous experience or experience that are occurring in certain projects that they've been working on. And as I mentioned earlier, you probably know us again for those Hacking Exposed books. So now that I have given you some info about us in Foundstone, I do want to start talking about some of the common challenges about building a software security program. This is, and as you see in the slide here, and I'm going to touch a little bit about this. This is based on experience of building software security programs for our customers, and also sharing experiences with people on the ground, on some customers and folks that have been leading such efforts for their organizations. And one of the common things that I heard from them when we talk about software security programs and running a software security program, one of the things that comes to mind is that they say at times is that, I feel like I'm herding cattle, and which is a pretty funny analogy, right? So, and one of the things that comes to mind when they say something like that, and it's being a few that has provided that analogy, is that if you're feeling like you're herding cattle, it's because you're not doing it right? You're not doing the right things. And as I will continue to mention through the presentation, it takes to build a software security program is a very complex thing to do, right? It takes a lot of people, process, and technology components, and all these components need to be aligned and orchestrated at the right time. Otherwise, if these components are not aligned and there's no strategic plan to it aligned with, say, like an external driver, such as PCI, for example, or SOX or any other compliance regulation that the organization needs to meet, if the strategy and metrics are there and the governance aspects are there and not there to guide the plan and the project roadmap, it can, at some point, it can feel like you're herding cattle, right? The other common challenges about building a software security program is how to provide effective risk management at the right cost, right? So reducing risk with an approach that is cost effective. And this is something that the banks and the financials are pretty good at, or they try to be really good at, because they care about the cost, right? And again, it's one of those things that, to give an example from some of the customers and organizations that I have worked with in the past, one of the common things that I've seen as an approach is to start with, say, like running a security scan of a web application or host, and they feel that that's, they're doing something. They have a somewhat of a program because they're taking some action by running some tests or running some scanners. And in the short term, it's cost effective. It's not as expensive as having to do some type of strategic approach. But in the long run, it becomes more expensive, right? Because when you start analyzing the results, you will see, for the most part, at least in our experience, you would see that some of the vulnerabilities that have been found from the scans, some it might be the case. Some have been that they have been fixed. But they might not have been fixed properly, so we're able to circumvent the fix and therefore exploiting that vulnerability again. Or it might be the case that they've been fixed, but they pop up in other areas of the application, right? So to give an example, if you have a cross-site scripting vulnerability on a login form that has been fixed, it might be the case that it pops up. Similar cross-site scripting vulnerability could be popped up in say, like a forum feature or blogging feature of the application. And this is sort of an example of common things that we've seen of organizations that have been trying to be proactive, but yet they're facing those challenges of building that security program by just taking the tactical approach with no guidance. And as I mentioned earlier, it takes this orchestrated set of activities and activities that have to be applied in iterative ways, iterative steps, to actually accomplish and make progress from a software security program point of view. Also, there's also an organization behavior aspect to this, right? Because the sense you're kind of trying to change the behavior and how the processes and how teams interact with each other and how they develop software. And one way that, in my experience, through my career, that I've seen this to work effectively and to change the behavior and to build a successful security program has been by applying some type of software security maturity model or program. So with that said, that leads us to the software assurance maturity model, which is the OWASP project that I co-lead, and is in fact one of the models that we base our methodology on. So it is important that you guys understand how the model works in order to continue with the presentation. So with that said, it is important to highlight that this is a simple model. It was created by Prabir Chandra. He's the creator of this model. And it's borrowed a little bit from things like the CMMM, the Capability Maturity Model from CMU, in the sense that there are some domains, some functions or domains, and there's also maturity levels that are tracked, some practices that are recommended by the model. But in this particular model, things are simplified because as you work with organizations, you will find out that as you want to build a successful security program, is that you got to take things slowly and step by step, and you have to simplify the framework that you're trying to socialize through the organization, so everybody understands what we're trying to do, right? So in this case, the way this was created was by looking at most organizations that develop software. And one thing that we gathered by looking, analyzing how they develop software is that most of them have some type of business function, such as a governance business function, a construction business function, a verification and deployment business function. For the governance business functions, basically, you would see the 3 best practices that are recommended by the model. In this case, you see strategy and metrics, policy and compliance, education and guidance. And then for the construction business function, you see things like practices such as threat assessment, secure architecture, secure requirements. So all these practices that pertain how to build or construct software properly and securely, right? And then for the verification business functions, we cover practices that pertain how to test software properly, right? How from early stages of the software development, such as the design review, which basically is a practice that involves looking at security, not at security requirements, but looking at business specs and software specifications against security requirements set by the business, by the security team, and also code reviews and security testing. And then finally, the business function of deployment, right? Because once you have constructed and verified the software, you want to have some practices in regards to how that code is going to be released and deployed. And therefore, these practices pertain to that function of looking at how the environment is hardened, vulnerability management, which most of you are probably familiar with, how these vulnerabilities are reported and how remediation is followed through once those are reported. And also operation enablement, which has to do with a lot of things like configuration management, code release, change management controls, and making sure that all of those are aligned to achieve security activities. So now that I described the business functions and practices, I want to highlight that for each of these practices, we try to have a maturity level, right? So you can see on the bottom there, we have maturity level 0 to 3. 0 really meaning that there's no practices being applied by the organization. Maturity level 1 meaning that there's some understanding and execution of the practice by the organization applying the model. And 2 meaning that there's some increase. We see some increase in efficiency and effectiveness of how the security practices are applied. And the maturity level 3 is kind of like that ultimate goal that you want to achieve, right? You want to achieve some mastery of security practices at a large scale and be able to scale those practices. And for those areas, for those practices that the organization is sort of meeting, but like say you have activity A or one activity to reach one objective, but you're missing one, we've assigned a plus sign to show that the organization for that specific practice is in between maturity levels. This next slide shows a little bit in depth of the details and the context for each of those, how to reach those maturity levels, right? And if you look at the OpenTime model, you will see that for every single practice, there is a section that describes each objective and activities assigned to meet those objectives. And in addition, some results that should be expected as part of as a result of applying that specific maturity level, or reaching that maturity level objective successfully. So in the case of objective one, and I should add that this one that is on the screen is a little bit modified for PCI compliance, because based on the case study that I will introduce, we focus on PCI compliance. So you will see some PCI context to it. But again, so for mature level ones, for this example, we have the objective to establish a unified strategic roadmap for software security within the organization, right? This is one of the first things that you want to do. Some of the activities that will allow the organization to reach that objective will be to estimate business risk profile derived from security development compliance goals, and also to build and maintain the PCI-centric software security program and roadmap. And as a result of that, you expect to have a concrete list of most critical business level risks caused by the software within PCI scope or applications within PCI scope, tailored roadmap that addresses the security needs for the organization with having very minimal overhead, right? Because you want to make sure that as you implement this, that you don't disrupt how the business operates. And also, one of the expected results is to have some organization-wide understanding of how the assurance program or security maturity program will grow over time. You know, what's expected as we start meeting all these objectives, right? Oops. So at a high level, for this particular case scenario that I will share, we provided a 5-phase project, or a project that was split in 5 phases. The first phase is the discovery phase. What we refer to the discovery phase, this is where we do the assessment and we're trying to understand, you know, what the current status is based on the model. And then we have once we have that information, we start building the implementation of the security program, right? So that's what we refer to as planning and awareness, because we start adjusting a little bit more the plan and putting more context to it. And in addition to that, we're trying to make awareness. We're trying to provide security awareness and socialize the project and the security program. The third phase is training and testing, and this is where we're typically focus on continue to train developers and conduct role-based training. And we want to continue to do testing, because even though that we have done that through the assessment, or we might have done that through the phase of the discovery phase, we want to make sure that we sustain those, and if there's any remediation that has been done, that we want to sustain those activities by retesting those applications and whatnot. And then the next phase will be infrastructure and architecture. And this is where we want to start focusing on how things like, you know, the environment hardening aspects of the maturity model, right? Like how where are these applications are deployed, how are deployed, any architecture guidance that needs to be emphasized through the process, and making sure that the hosts where the applications are deployed are secure. And lastly, we have the governance and security operations phase. And this is where we kind of go back to this governance aspects of the program, like the security, strategy and metrics, education and guidance, policy and compliance, ensuring that that if there's any maturity objectives that have not been achieved, that we verify those and try to reach those at this phase, and also focus on the operations aspects of, like, making sure that any procedures and any new processes that have been established or have been changed as part of getting change management controls tied to security operations or security changes, that there are basically enhanced at this phase. So for phase one, as I mentioned, is the discovery phase. In this particular case, we started by providing a questionnaire. Questionnaire based on the OpenSAM questionnaire, which basically looks at these practices. Let's say, for example, if you're looking at the code review section of the questionnaire, we ask whether are you doing any code reviews, and if you're doing some code review, how you're doing it. Are you doing peer reviews? Are you using any code analysis tools? Are you integrating those code analysis tools as developers are building the software to trigger any security concern, any security issues that may be already introduced by someone else through the development process. So we start with a high-level questionnaire, and then we try to dig deeper into understanding how the organizations develop software and how they take into consideration any security activity, which is considered, that will be considered a best practice by the model. We interview also stakeholders on the development process, say like directors of application development, all the way down to the senior developer and development leads, and we're trying to understand how they develop software, how they practice, what type of methodologies do they use, have they done any training, any security training, do they have any security requirements, do they have any guidelines, and things like that. We also try to reach out even to the QA leads, project managers, and also even security testers if the organization has a team already in place for that, to try to understand, you know, what is their function, and how their function applies, how their role applies into the whole development process. In addition to that, we also ask for artifacts ahead of time. So if there's any diagrams, and also, well, I may add that through the questionnaire, we also focus on the applications, right? So we try to ask, you know, what are the applications that are critical to the business? Are they handling any credit card information, or are they handling any PII information, any of the sensitive data that they will be interested in protecting? And then we ask artifacts that are relevant to those applications or those projects. We refer to an application as a project through the model, as the implementation. And then we'll analyze these artifacts such as design diagrams, data flow charts, any valuable information, documentation on how you know, process documented on how they deploy the software, how they deploy any fixes or any patches and things like that. And in the process of analyzing this, we also try to basically build a business risk profile in a sense, and also start to build an application risk portfolio. And I will talk a little bit deeper into that as I start going through the different phases of the presentation of the security program. In some cases, in this particular case, once we provide all this information, we provided a benchmark deck, basically that represents the status of the organization, right? So we were able to show, you know, this is based on the model. This is for a threat assessment. Basically, you're not doing anything, or you need some work in here, or for strategy metrics, you need to adjust this, or you need to start applying these activities to meet this certain maturity level. And in this particular case, once we provided that, we also suggested that, you know, let us follow up with an audit, right? Because these first steps are great at providing a benchmark and kind of like a health check of how the organization is doing. But we also want to try to understand in an in-depth analysis, get an in-depth analysis of the secure development process or secure development life cycles that are being in place in the organization. So we'll follow up with an audit step where we start looking at these applications, and we started doing web application penetration tests, because for the most part they were web applications. And then we started conducting core reviews of each of those applications. And in addition to that, through the Foundstone methodology, which actually reaches out a little bit into the environment where the applications are hosted, we're starting doing host configuration reviews, and we got approval to get some of this data. And that was, it actually turned out pretty good, because we were able to get enough data and specific data to provide more context as to how the roadmap was going to look like at the end. And then once we're done with the phase one, what you want to do really is you want to provide some type of checkpoint, right? And the checkpoint should come in this case, in this particular case, what we did was we provided a slide deck and a presentation, and we got senior management and C-level executive to join the call, and all the stakeholders of the development process to join the checkpoint review. And then in addition to that, we provided a technical report that had all the details. But the checkpoint deck basically showed the scorecard, final scorecard that we came up with after the benchmarking and after doing the audit. And we also provided a specific project plan and a roadmap of how we were suggesting for the organization to start fixing and remediating these gaps that were as a consequence of the assessment, right? So I wanted to highlight some of the key benefits of this phase, because it is really important as you start building a software security program that you have this assessment aspect of it down into the detail. And what this approach helps with is that it provides a quick benchmark approach to be able to map what the organization is currently doing in terms of development practices and secure development practices against what is recommended by the model as best practices, right? So if they're not doing code review, if they're only doing security testing, like running some automated scan or something, we obviously the code review will be something that will pop up on this benchmark and something that we will recommend, right? Because you want to make sure that you test software properly on all stages of the software development process. And in addition to that, it shows it highlights all the gaps specifically from a secure development lifecycle point of view. So it doesn't just show the governance aspects of building software, but we like I mentioned previously, it covers those constructions and verification practices and aspects of software development, which helps from a technical point of view. It helps drive the secure development life cycle. You also help us gathering more information and supporting evidence through providing risk-based testing, and it also helps us starting how to improve the software security posture for the organization. So some of the key findings that we gather from this particular case scenario, we broke them down into people, process, and technology gaps. And for this case, this organization was basically starting from scratch in a sense, and we found out through the results of the assessment that from a people gaps perspective, that they did not have a secure software development training program in place, that they did have some sort of a strategy from a security program point of view, but it was not fully aligned with external compliance driver, in this case with being PCI. And from a process gaps, they were missing a lot of these security practices that are recommended by the model, right? Like secure architecture practice, design review, code review, security testing, vulnerability management. Also, from an operations point of view, they did not have a good process on providing or building, web servers, file servers, database servers. And also, they were lacking from a process gaps point of view. They were lacking change controls tied to security activities. So there were some change controls sort of in place, but they were not really tracking any security activities. Reason being because they were not there either, right? But this is one of those key findings that are important as you drive and build a software security program, to have change controls to track these activities. Technology gaps, some of the technology gaps that we highlighted as a result of the assessment were that there were tools in place already from a security tools point of view, but they were not integrated with the development environment. So they were there, but they were not being used, or they were not integrated to the tools, to the development tools. So they were not being utilized efficiently because they were not integrated into the development process by providing a practical way for developers to test their applications. And another gap was the fact that there were tools, as I mentioned earlier, but those tools were there just for automating some things, like running a security vulnerability scan, for example. That was one of the tools that they used the most. But it was not fully integrated with all these other processes and how to report those results to, for example, using something like TFS. So at the end, I think I mentioned this as part of the discovery phase, and one of the things that we provided on the checkpoint. I want to highlight this as part of a software security successful, or building a software security program successfully, is to provide all this scorecard information, right? So this is an example of scorecards of one of the case studies, one of the customers that we worked on. And you want to basically highlight, as you see on the left-hand side, you want to highlight the current state versus what the future state that you want the organization to achieve. So you can see, for example, the start would be the discovery phase, where most of the practices were indicated as 0 or absent, with some security testing because they were using some security scans. And then you see the other phases. Basically, you want to highlight what you want to achieve as you move through the different project phases. So you want to go from a strategy metrics of level 0 to a mature level of 1, and so on. And you want to highlight all the way to the last phase. In this case, I was just representing the 4th phase because we were waiting for some of these phases to be achieved in order to start providing some more input on how phase 5 would look like. And in addition to that, I mentioned that this scorecard on the left-hand side, this is what is included on the first technical report as part of the assessment. But as we start moving across different phases, or I should say from phase to phase, let's say from phase 1 to phase 2, at the end of each phase, we try to provide a checkpoint and provide a checkpoint status scorecard as the one you see on the right-hand side. So that way, the organizations, all the people involved on the program, the security program, they can visualize. Okay, so we started on level 0, and now we're level 1 on this phase 1 for strategy metrics and for policy and compliance. We started on level 0, and now we're mature level 1. So it's really good to, as you build a software security program, to highlight these changes and provide the information in a way where it's easy to consume by all the stakeholders. One thing that we included on the checkpoint index is also this roadmap / timeline. And this has been pretty effective, and it was actually a suggestion by one of the organizations that we were working on. And it has been working very well. It's also good to kind of show what the success metrics, right, and broken by the timelines and project phases. And as you can see on this roadmap, you can see that, for example, on phase 1, we accomplished getting 80% or more coverage of security testing of the top 10 applications that we selected. And then we also did 80% or more code review coverage of the top 10 applications that we selected as part of the application risk portfolio. And the green circles basically show that we have already gone through these phases, that we have already achieved these success metrics. And also we want to highlight where we are, which is highlighted by the blue circles. And then the red circles basically highlight where we want to, where some of the phases that we haven't gone there yet, and we're not providing any success metrics yet because we're sort of waiting on the final results of the previous phase before we can adjust some of this. Because as you start making and implementing the security activities and you look at the checkpoints, sometimes you will see, that maybe you're not doing enough security training, say for developers. And one of the indications of that is that the applications that we're testing now, and they're part of the focus for a particular case, you can see that the developers are still introducing security vulnerabilities such as the cross-site scripting vulnerability, right? So then you know that the education and guidance has to shift a little bit by improving how that training is going to be, right? So instead of being so high, maybe it's too high level, or maybe we just talked about reflective cross-site scripting, and then we want to show the historical cross-site scripting and how to fix that for a particular framework. To give an example. So all of this is provided through the checkpoints and making sure that you are adjusting your activities as you start making progress through building the program and applying the software security program. So now I'm going to start diving a little bit more into the phases. I already discussed like the assessment phase, which is what we refer to as phase 1, the discovery phase. And then once we have all these results and we have already the roadmap and we have already a good understanding of what applications to focus on and all those things, so all the first steps, then for the most part, when you're building a software security program, you want to the next step is to strengthen the governance aspect of it, right? Because especially if you're building it from scratch, and that being that you got to start working on how the education and guidance practices is going to be applied, how the activities are going to be applied through the organization, what policy and compliance is the program going to be focusing on, and what strategy and metrics, what strategy you want to have, what kind of metrics you want to collect to keep driving that governance aspects of the program. And for this particular case, what we did is we established our strategic software security roadmap by, as I mentioned earlier, by choosing top 10 applications that handle credit card transactions. They were basically the applications that handle all this credit card information. Some of them were, most of them were applications. Some of them were actually components of these systems, and therefore we grouped them on the same list. And in addition to that, we wanted to look into the education aspects of how to apply this strategy, right? So we started conducting 15-minute security brown bags. And in the brown bags, we chose, well, before I get to the topics, I should mention that something that was really helpful was by delivering these brown bags and grouping the stakeholders in different groups. So in this case, what we did, we set up a builders group. So those that were responsible for building code, like developers and dev leads and software architects, we put them into that group. Those that would test software and run like security testing or web application security scans, we will group them into the breakers group, and then we'll have a defenders group, which basically was composed of all the people whose responsibility were to defend those applications. So ensuring that, like project management, to ensure that there was remediation being done from all the findings. Also, like operations teams, like people that handle firewall rules and whatnot. Server ops team to make sure that they were patching the systems. And as we group them in these groups, we built security brown bags that were basically customized to what their functions were, right? So, for example, in the case of the builders, we started with application. Actually, I should say that in the case of the defenders, like managers and project managers and senior management, we started providing security brown bags that were focused on application security risk. So it was like basic information on, what software security risk, what application security is so important. Why are we implementing this type of maturity model in the organization, and so on? How this model will fit into improving the software security postures for the organizations and whatnot. And in addition to kind of educate them into the risks associated with application development, we also fit it in socialization of the project and roadmap, how we were basically tackling those risks. We also conducted like PCI for the developers or builders point of view. We focused on PCI OWASP Top 10 and SAS Top 25 in this case because the PCI compliance was the main driver. And as I mentioned earlier, security development lifecycle type of training and or security awareness, I should say. We also, from an education and guidance point of view, when you're building a software security program, and based on this case, something that we saw that worked very well was building that knowledge base or repository of providing guidance to developers. If you're in an enterprise organization, like it was the case of this case study, you want to make sure that the guidance is not just that doesn't have too much information that is not going to be relevant to specific groups, right? So you want to, for example, if you have a team that develops in .NET, you want to make sure that you provide short guidance and it's specific to applying or fixing or avoiding vulnerabilities such as described in the OWASP top 10, right? Like cross-site scripting, SQL injection, cross-site request forgery, et cetera, et cetera, et cetera. And as you do that, you want to make sure that it's all centralized and there's a process on how this documentation is updated, also QA'd. So it provides some realistic context, not just some guidance that it was taken from some wiki, right? You want to make sure that it speaks to the developer and makes this practical to them. And we also want to start building standards and policies. So from our policy and compliance, you want to make sure that you have all the secure development policies and standards written and in place and socialize those. And you start establishing project audit practice as you start working from a policy and compliance point of view. In this case, what we did that was extremely useful, and I could see that also with other orgs that I have worked on. It was to kind of provide how we can meet those requirements for PCI. So PCI being the external driver, what we did was we looked at the security practices by the model, right? And then we turn online those practices and how they apply to each requirement, right? So for requirement 1, for example, we noticed that environment hardening and operational enablement has some activities that basically tackle that requirement. And as you can see for requirement 6, is mostly all of them are basically tackling that specific requirement. For phase 3, this is when we continue to do training and awareness, but we start stepping up the training to focusing on the developers and providing more technical training and hands-on to those developers from an education and guidance aspect. We did continue again with the security and brown bags, and some of the technical training that we did was basically, it was already focused again on the OWASP top 10 and on the PCI requirements, but they were very specific from a technical aspect of how to avoid cross-site scripting on the .NET applications, how to fix SQL injection, how to avoid SQL injection on the .NET applications. And we actually had hands-on activities where the developers actually they have a workstation aside, and they will go through a lab exercise. So it wasn't just a theory type of training. We also enhanced remediation and guidance because at this point we start to building and providing more checklists. So we provided checklists for code reviews and web application penetration tests and host configuration reviews to show the business and share with the business what kind of things we were looking for as we test them, right? So that way it kind of gives them a perception, or gives them some information as to what we're going to be looking for as we start testing their applications and environment. We also provided more guidelines, again, specific into like the writing secure code in the .NET and Java applications, and providing hardening guidelines as well. And we started to conduct more reviews as part of the testing aspects of this phase. We started to expand our code review process to other applications, and ensuring that we're not just doing things like a vulnerability scan or a web application vulnerability scan, but we're also trying to encourage them and work with them to build unit testing to test for certain specific security vulnerabilities on the code. We started working with them also with their environment. So in this particular case, it was the .NET shop. So we started working with applying like cat.NET and FXCOP, and offering guidance on how they could do that on their development environments, and how that could help us automate aspects of that process. And we also, from a vulnerability management point of view, at this phase is when we start establishing contact information and response team to application security-related events. So this is where we created what we call we created a software security group, basically. And we make sure that everybody was aware of it. We created an inbox and provided forms and ways where they could communicate with the team. and therefore, if they had any questions or concerns, or they wanted to request some guidance, that could be done through this response team. So the next phase, phase 4. For phase 4, we basically focused on the infrastructure and architecture aspects of providing the building security program. So this is where we, at that point, once we have gone through phase 2 and 3, that we have touched most of it, like the governance aspects of the program, and a little bit of the testing and a little bit of the deployment aspects of business functions of the model. We wanted to start working more into the infrastructure aspects of it, and also the architecture recommendations, which basically applies to like the construction business functions of the model, right? So here we start looking at how to build a threat assessment practice. So meaning that once that we have all those applications established, those top 10 applications, through the process of testing, we do perform some threat modeling, but we want to make sure that we start building a practice around that, right? So if there are any other applications that are going to be built, or some modifications, features that are going to be added to existing applications, that the development team and the business were comfortable enough to come to the security group for a threat assessment, right? And we, in the practice, will have to be documenting all the attack surface, understanding what the who, the what, and how, the impact versus likelihood, and provide diagrams of all the components that make the application, and thereby showing and highlighting the use cases scenarios versus the abuse cases scenarios. So we have a really good understanding per application or per project of what the threats are, right? So again, another aspect of that maturity process where you want to start building it and strengthening that program. We also started working on security requirements guidelines and enhancing and modifying and updating those requirements as we start understanding more and working more with the business and being embedded on their team. And we also start on this phase to start working on the secure architecture, which is really key to building secure software, right? This is something that I don't hear that many people talk about, but secure architecture is so important because you're basically tackling the security problem at the early stages of the design and avoiding security defects from a side aspect on the software. And to give you some examples, some things that we have worked in other examples, in other organizations, have been like working with dev teams to provide guidance on how to implement the enterprise security API, for example, or providing some type of API, security API that is centralized, and any other parts of the organizations that develop software can utilize. So rather than building their own little functions, we could leverage a central library that they could just include into or import into their code, and they just code specific methods or classes. Another example is, for example, using the HTTP.utility class in .NET, right? So you can use to provide encoding, so that way you're fixing cross-site scripting at that level. And then we also start working on the design review and strengthening that process, that practice, and providing that as a service to the dev teams and most important to the product managers or project managers or software architects, which are most of the folks that are involved in these early stages of the design, and thereby basically looking at what all the documentation, all the specs that they will have provided for that at that stage of the development process of the design of the software, and then match that looking at the security requirements that have been already shared and established. So that way we're ensuring that that they're doing like fail logging attempts, for example, on the design, that they're doing resetting the password properly, or having a forget password functionality properly, taking into consideration security requirements already shared. And then we also want to strengthen a little bit more of the code review process to ensure that we're tackling all the applications, and then we start expanding a little bit into other applications to ensure that they're not just being tested from a dynamic analysis view aspect, but also from a source code review, so source code analysis. And this also from my infrastructure, we tackle a lot of the environment hardening. So we start looking at a lot of the environments and components of the infrastructure that could affect the application overall, and ensuring that they were compliant to the hardening guidelines that were already shared with them. And if there were any modifications, any adjustments, or we have to build another one because there was another environment that was set apart of some changes to one application, that that we take that into consideration and adjust that as we continue to build the program. So for phase 5, which was basically the last phase for this particular case scenario, we felt like we already done a lot of work on the governance from the beginning of the program. Then we focused a little bit on the core aspects of building secure software, like the construction, the verification, and now we want to kind of go back to that governance, to those governance activities, and also look at a little bit more into enhancing the secure operation related activities, right? So we looked at in a way once we have provided all these checkpoints and provided how the program is actually working from a technical perspective, like we're finding all these issues through a code review, we're finding all these issues through a web application penetration test. We also wanted to show what, from a risk management perspective, what does that mean, right? So we started to document those metrics for secure expenditure, and we also started looking at industry-wide, looking at comparing the costs of using different tools or taking different approach, tackling specific software security problems, right? And then take that context and feed it back to senior management, so they will understand and they could see the value of the building the program successfully. And also this could help us if we were spending too much time on the licenses for some tool that were not really being used. We know that we need to adjust a little bit our strategy here, perhaps, and stop using a tool or looking for other options that will provide similar information without hitting us on the wallet too much. And from an operational enablement point of view, where I refer to also secure operations, we're starting to enhance how things were coordinated in terms of releasing software, making sure that the group that was in place of configuration management and building the software, that they knew how to use the change management tools to track these changes. And we also start working with them to enhance how they could help verifying certain things and securing providing security configurations to the software that was deployed. One example I can think of is we helped them deploy a tool to verify like web.configs on .NET applications. So once the application was deployed to a production environment, they could run the tool, and then they could see if they could flag whether the web.config or the app.config has like credentials stored in plain text. To give an example of whether we're not using the SSL attribute on the configuration to enforce SSL through the application. And as you do that, you want to document all this, and you want to make that into a process. So as the new releases are going into place, and you're trying to mature other projects and other application development teams, that they start looking and copying these activities and ensuring that they're moving forward with them. In a sense, at the end, what you want to achieve from a secure development lifecycle is something like this, right? Where you have quality gates to enforce some of the security activities, right? Like in the case of the design stages, and they have some design documentation, and you want to have the quality gates of design review there once you have approved all the requirements. And for this particular case, we were looking a little bit about PCI, which talks about segmenting the environments and providing access to certain folks in certain environments. So This is sort of what you want to achieve too, right? Where you want to have only access to developers for development environments, and you don't want to give them access to a production environment, and so on and so on. Some success metrics are part of this: 80% of applications in compliance with policies and standards, 80% of staff knowledgeable about policies and standards, and 80% of code review coverage for those top 10 software applications. And you can see basically some of what we were able to achieve by setting these metrics and ensuring that we were achieving our maturity objectives as we work with different application groups. And quickly, I want to mention this, which is also very important about building a software security program, is leveraging the right tools, right? So in this case, we leverage Team Foundation Server from Microsoft, and we make sure that all the important applications, all the critical applications of the business were managed from an application life management cycle aspect through this system. And then we start adding basically security-related fields, so we could track things like, security bug latency, how many bugs were being introduced, how many bugs were being closed, how many were active, and so on, and then be able to relay that information back to management so we could continue to drive those remediation efforts. So in a summary to wrap up, because I think I'm running out of time here, we talked about the software security maturity assessment methodology at a high level. We also talk about the fact that we based that on the open SAM model, which talks about governance, construction, verification, and deployment. And each of these business functions has a practice and 3 maturity levels associated with that practice, and that it helps us do a SDL, or security development lifecycle gap analysis. We also talked about I provide some of this information through the case study, and I hope that was informative for everyone. And some of the key benefits that I want to highlight here are that, taking this approach and building a software security program this way, it really helps to provide a comparison of current security development lifecycle activities versus what is recommended or what is seen as best practices. And it also provides a cost-effective approach because you're guiding the activities at the right time and through the right team members and the stakeholders, and ensuring that everybody is communicated in the process. And most importantly, taking small iterative steps towards maturing and improving those processes. And also providing this approach of building a software security program, it provides this different model, these building blocks. It makes it really flexible to apply to any size organization or in any industry, in our experience. And that's what I got.
All right, thank you very much, Kwai. So we did get some questions in, and for those, we'll address the email. Unfortunately, we did reach right up until the end of the time slot, so I'd just like to thank everyone for their time. If you do have any questions, you can reach us at sales@foundstone.com, or you can contact us via Twitter at Foundstone. Thanks again for your time, and have a wonderful day.